Hello everyone, I'm Rohit Gupta and I'm going to discuss my CVPR 2023 paper, Class Prototypes Based Contrastive Learning for Classifying Multi-Level Finding Educational Videos. This work was done in collaboration with my mentor Anirban Roy and other researchers at SRI International and also my academic advisor Dr. Mubarak Shah at the University of Central Florida. Young children in the age group of 2 to 4 years old now consume 2.5 hours of online video per day on average. Uh, you know, Watching appropriate educational videos can support healthy child development. The motivation of our work is to help parents, teachers, and media developers increase young children's exposure to high quality educational videos. In order to support our research, our team collected a new dataset of online annotated videos called Approve. This dataset consists of curated educational videos from a popular online platform. These videos have been expert annotated with 19 labels. These 19 labels consist of 7 literacy topics, 11 math topics, and 1 label reserved for hard negative background videos. These cover topics commonly taught in pre-kindergarten and kindergarten classes. In all, our dataset consists of 193 hours of labeled video. These videos are labeled at a fine-grained level, and each video can have multiple labels corresponding to all the topics taught in the video. Comparing our work with related prior datasets, we find that our dataset is the first video dataset to be multi-label as well as fine-grained and multimodal. In order to highlight the fine-grained nature of our dataset, we show some samples from our dataset corresponding to various literacy topics, math topics, and background category. So within the literacy group of categories, we see videos from classes such as letter names and letter sounds. These videos visually resemble each other, and hence distinguishing these videos requires a fine-grained multimodal understanding of the video. As a result of being collected from real world educational channels, our dataset has a long tail power law and distribution of labels. There are many challenges that need to be addressed in order to solve the problem. First of all, fine-grained classification into such similar classes requires multimodal fusion. Since many of the classes are visually similar, understanding the speech and audios in the video is also very important. Additionally, we note that existing contrastive learning based approaches have reported strong performance in fine grained classification. However, supervised contrastive learning is limited to the single label case. Uh, we propose class prototype based contrastive learning, which solves two problems in one shot. First, the use of shared prototypes across modalities allows for alignment because features for video for the same video across different modalities are pulled together towards the class prototypes. Generalizing contrastive learning to multi-label setting can also be achieved through the use of class prototypes. The video features are attracted towards labels of class prototypes of labels which are present in the video and repelled from labels which are not present. Finally, our multimodal fusion encoder is able to successfully merge features from multiple modalities. Here's an overview of our method. As our goal is to achieve multimodal understanding of the video, we obtain both video frames as well as speech recognition text from a given video. The speech recognition text is processed by a text encoder branch, whereas the video frames are processed by an image encoder branch. Our multimodal fusion transformer encoder merges the information across these modalities. As a result, we obtain features for the text modality, for the video modality, as well as the multimodal features. Our proposed class prototype based contrastive learning approach is able to align the features across all these modalities as well as successfully achieve contrastive learning in the multi-label setting. Next, we discuss our multi-label contrastive learning approach. In this approach, along with the encoder network, we also learn class prototypes. So, for a given video X1, which has two labels, ground truth labels, orange and green, it is encoded through the multimodal encoder, and finally the feature representation is attracted towards its ground truth labels, orange and green, and it's repelled from other labels such as blue. Similarly, for other videos like input X2, which has the ground truth label blue and green, it is attracted towards blue and green class prototypes and repelled from the orange class prototype. In this slide, we discuss fine-grained video classification results for our proposed approved dataset. We provide a breakdown of results across the full dataset as well as results specifically for the math and literature classes. We present three metrics: area under the precision recall curve, label ranking average precision, and recall at 80% precision. Uh, our method is able to outperform prior baselines such as binary cross entropy, focal loss, and asymmetric loss. We also evaluate our method on a 1% subset of YouTube 8 million dataset, which consists of 46,000 videos. Here we observe our method provides significant gains over binary cross entropy as well as focal loss. Even in the single label setting, such as task classification on the coin dataset, our method outperforms strong baselines such as supervised contrastive learning, focal loss, and cross entropy. Thank you. For more details, please visit our project website uh, in order to obtain our dataset as well as code.